Hello, ground branchers, brancheros, whatever. So I said I'd do a video showing some of the AI stuff in Unreal Engine. So I thought I'd do a quick sort of intro to what's actually in Unreal Engine right now. So here's my prototype test bed. You can see it's pretty basic. It's just for testing stuff. And right now I'm testing a thing called the environment query system. So let's just show you that in action. If I switch on this guy, and for some reason it's not actually showing the. That's because I've not switched it on, that's why. There we go. So every just switch off the behavior tree so it doesn't flicker quite so much. Ooh. Yeah, it's just my little implementation of leaning. Okay, I know what's going on there. I switched off the AI debug. So going back to that, if we show, there we go. So the EQS system, I'll switch off the other ones for now, perception, etc. The EQS system, if I just eject from this guy, if I just eject from that guy, there we go. So I'm just using some prototype characters and stuff. Oh, you can't see the EQS system without me doing that. Yeah, so brilliant, isn't it? So the EQS system is essentially a way of querying the world. So right now what I've got is a query that's trying to find a point away from me, me as the player, that this guy can stand with. Now, right now, there's some bugs in the EQS query that I've done. Because most of these nodes should be blue, like these trace nodes, because they're saying yes, you have got a line of sight, but some of them are not, so clearly something wrong. And this guy ain't getting out of there. So the other fun thing is that the line of sight trace for this is actually not coming from the eye point, it's coming from like the center of his torso kind of thing. So obviously he's thought that he was away from me when he just did that query. So the query's happening, like, I can't remember, every 5 seconds or something crazy like that. And all it means is essentially find me a point in this path of points. Now this is nothing to do with the yeah, I didn't really want to crouch, did I? This is nothing to do with the actual sort of navigation stuff. This is more to do with like generating random not random points, these are points on a grid, but there's different types of query parameters I can use for saying, find points around me that don't have line of sight or that do have line of sight, etc. Now, there are obviously some issues here, but you can see that it's kind of mostly doing its job, and I've still got to refine things like where the actual line of sight center is and those kind of things. So that whole system is part of, if we just think about the sort of AI stuff in Unreal Engine. So the world itself is using a thing called navigation graph. So it's basically this kind of green mesh here, and that navigation graph, let's see, can I get a cube and just plug it down, is, if you see here, is kind of runtime generated. So if I move this guy around a bit, you'll see that it updates itself as you move. Which is obviously what you want, because if you've got physics-based objects, you can make them kind of block the navigation and whatever for the AI. But there's a problem in that this navigation graph, just trying to think what the somewhere in here. If I show you the, not the triangles, is it? Poly edges. Yeah. Okay. So this is the actual sort of navigation. You can see it's split up into these really fairly large tiles. Well, that's a configurable bit of data. There are lots of properties that you can play around with the navigation graph, and that's important really, because one of the things that we need to do is to mark some of this stuff as tactically, what's the best way to say it? So imagine this guy's an AI, and he's got an arc of fire sort of coming out from there. You wouldn't necessarily want to have your characters walk across in front of him. So it needs some kind of tactical information to be encoded in the parts of the nav mesh that can be seen by this guy. And that isn't really available right now. One of the first things I'm planning on doing actually is I'm going to take the edges of this nav mesh, so you can see the sort of edges of places where they could potentially kind of hit some geometry, and I'm going to build a whole bunch of cover positions based on that information, which means that I'll have to do things like handling the rebuilding of the cover positions as objects move around in the world. But given that information, that sort of this idea of building things on a mesh, on a grid for this guy will be a lot simpler, because I won't have to do the actual, I won't have to generate a grid of points. I can just generate cover points essentially, and a sort of sparse grid of points as well as that. So essentially the cover position information will suggest that you can like stand behind cover and squat down and that kind of thing. So if we look at the other parts, so that's the navigation graph, navigation mesh, sorry, is kind of a normal thing in especially first-person shooters these days. It means that you can like navigate over space. It gives you a fully navigable area. So basically anything on the green mesh, your AI can get to. Now obviously there's some islands here that you can crop those out with some special things, but essentially it means that the AI can path anywhere it needs to in the world to get where it needs to go, which is obviously more useful than what we used to have, which is we used to have like a path of points, like pretty much like the path generation here. You know, we used to have like this grid here that you see in the sort of green circles. We used to have that as the only way of navigating around a space. And obviously, if your path didn't quite go along the waypoints, things got a bit hairy. You know, you could fall off ledges and fall off bridges and those kind of things. So you don't really have that anymore in modern AI. So the other part of this stuff is the behavior tree. So this is the behavior tree for that guy, and obviously it's just a sort of silly work in progress for me testing something out. But the behavior tree here is the way that we sort of set up what the decision making logic is. So in this case, the selector is selecting one of these branches, sets of trees, treelets, whatever. And we've got a bunch of conditionals. So if I've got an enemy set, I can face him, check whether I've got line of sight. If I have, I'm going to run that query to find out where I can move to that point, go in there and wait, and I've switched off the shooting for now. So obviously this is a really rudimentary tree for testing, but you can imagine that the tree will get quite complicated in terms of like decision logic and those kind of things. So when you run it, you can see at debug time, let's just get that guy running in, and then you can see the execution. Okay, so he's moving around the world, he's waiting. You can see the execution of the actual tree itself. And you can debug things a little bit that way, but honestly, it's not the most easily debuggable thing in the world. So the behavior tree is kind of the decision-making thing, and then there's a whole bunch of these things, right? These little tasks, and the tasks are, or will be, called actions eventually. And actions are things like, pick up a thing, or shoot at a thing, or move to an area, or whatever. So you define your AI in a number of classes. So in this case, I've got this what's called a blueprint class that defines what the character is, but it also defines, it uses a thing called a controller. So the controller itself, in my case, is responsible for doing a little bit of perception. So basically the controller figures out that there's something to perceive using this perception component. And there's a couple of senses that we can use here. So I've got line of sight, or rather the sight sense. I'll show you that in a second in the actual game. And a hearing sense. And there'll be a whole bunch of senses. This is kind of still a little bit experimental in the early Unreal Engines, so it's fleshing out a little bit now. But the perception system essentially gives us ways of perceiving agents, and in this one I'm just getting whatever I perceive and saying it as a threat, essentially. So eventually this controller will be hooked up to a whole bunch of different senses, and that feeds information into a thing called a blackboard, which is used by the behavior tree sort of decision logic as a sort of data store. So these are the blackboard values in here. So if I just go to the blackboard, you can see these things kind of store the information that we need. So what's my cover position, who's my enemy, that kind of thing. So it's actually kind of a reasonably complete system, but there's just a whole bunch of things that are missing for tactical use, mostly to do with things like there isn't any hierarchy, so you can't have, so the characters are sort of totally independent right now, and obviously we need a squad of characters, so we need some way of communicating between them and communicating, which task each person's going to do in the squad, that kind of thing. So there's no notion of squadness there yet, so I'll have to add that. Again, the tactical sort of stuff, like marking up the world to say what's threat and what's not, what's safe ground to move across and what isn't, where the potential threats could be and that kind of stuff. That'll come from the cover point generator, I think, most of it, and maybe some what's called an influence map, which will basically form a grid that provides extra information when we're doing queries. So the other fun part, which is just the thing I've just done now really, is the environment query system query generator. So the EQS system is again in multiple parts, but what you're essentially doing is you're defining, in this case we're saying create a pathing grid, so create a grid of points with an extent of 2000, and there's spaced every 2 meters. This is check to see if you've got a path to the item, and the context is the querier that's calling it. So basically the enemy bot is saying make a grid of paths around me, check if I've got a path to them. And then the other part is the context, and the context is the bit that I was having problems with until, well, a couple of days ago when I was just trying to figure all this stuff out. And the context basically says it provides information to the system so that it can run a line trace essentially between the enemy, in which case it's us the player, and the AI to say, have you got a line of sight to me? And what that means is that we can essentially call out or set some values on this path, this grid of nodes, to say whether they've got line of sight to the enemy. So you should theoretically always get a point that doesn't have line of sight, but because the line of sight's a little bit messed up right now, sometimes you get a point where there is technically line of sight, but the system thinks that he hasn't got line of sight because it's in the middle of the capsule of the character. So easy fixes there, really. There's quite a lot of foundational stuff that's actually usable. And the CQS system is pretty flexible, although it's completely undocumented, so I had to figure most of this stuff out as I was playing with it. So that's it, really. It's just sort of, I've been figuring out how the current systems will work. A lot of it's kind of work in progress still. There's a guy called Mishko at Epic who's doing the AI code, and often I just have to bug him about stuff that I don't quite understand. He's really helpful, but there is literally no documentation for this kind of stuff, so you just have to read the source code and figure it out sometimes. So the parts that we want are parts like figuring out the environment, working on squads, and then just doing a bunch of sort of maneuvers and basic behavior tree stuff. So I'll be doing a lot of this kind of editing. And hopefully we'll maybe make some simpler tools that you guys can use. So one of the things that a lot of AI design talks about is how complex do we need to make these behavior trees? So some companies have literally 5 or 6 nodes in here. One would be an attack node that just deals with every kind of attack. Whereas I like to keep it kind of separate. So things like movement is maybe one thing, and then firing is maybe another thing, and then we've got random weights in here just because. So it's a matter of how complex we need to make this interface, and I'm not sure eventually I'll maybe replace quite a lot of this stuff, but I'll show you that when I get to it. So put it this way, it is a work in progress, and to be honest, the engine's AI systems are a work in progress, so a lot of the time I'm kind of half figuring that stuff out and half figuring out what I want to do with it, and well, that's 2 halves, and the third half is that I'm trying to figure out where we want to go and what new systems we'll need for the AI. So I'll be showing you more of this prototyping as we're going along. It is useful to do prototyping like this, although I kind of need to get it in the Grand Branch code base fairly soon anyway. So what I'm kind of working on really is just sort of poking at these current systems and just seeing what their properties are, what their failure conditions are, how to tweak them, that kind of thing. It's kind of it's a crazy thing working on air, because obviously the guys obviously do some pretty nutty stuff sometimes, and figuring out the edge cases for that isn't always the easiest thing, but it is fascinating to try it, so look here, why did those nodes generate up there? That makes no sense. A lot of these guys, these nodes should be blue, and they're not. And you shouldn't be standing in the middle of the area anyway. It's probably because, if I go to the cover query, I can turn off the random, because I've just added a little bit of random variance in the cover query just to see what would happen. So getting back in here, switch on the there we go. Oh, I see, yeah, some of the tracing was. So let's follow him around here. He should go off in that direction once the weight state goes out. So there's a whole bunch of sort of AI debugging things I can switch on and off. You'll see there's, oh, that's what I wanted to show you as well. Let's just eject out of here. And of course you can't see it. Can you? No. Let's just stop that. Go to simulate. And is that? Yeah, okay, that's good. So if I switch off the navigation mesh, you see these circles? I don't know whether we talked about it in a thread, but the idea of sensing stuff, well, the perception component I showed you on the characters has currently two sets of perceptions. One is the sight perception, which is this green circle, right? So inside the green circle, this guy here can actually sense things that it sees. So you'll see that he's actually got a sight position for this guy. You see where the line of sights are kind of screwed up, because the line of sight's coming out of his chest there and going to his groin there, which is probably not quite the right line of sight. So it means that things that you perceive are inside the line of sight, and then there's a sort of lose line of sight thing here that says, like, once he goes past this radius, we don't know where he is. So you can kind of do a sort of partial lost sight kind of event kind of thing to go and hunt for them. And the same for hearing. Basically anything hearing in a certain range will, I think the hearing range is this yellow guy here, so anything in that range he'll hear when it happens. Now what I haven't shown you here is that I'm just updating my suppression system to offer some more information that I'll then feed into this perception system, because the perception system's fairly new. But that'll mean that you'll be able to perceive when you're being suppressed, which means that then the AI system can react to it, preferably by firing back in roughly the right direction, that kind of thing. So there's a lot of systems already there. Let's just switch off one of those things that's flickering. Okay, so I'm just doing it. Yeah. So these guys kind of go a bit crazy. I like doing prototype guys. But anyway. And this guy's perception's only 90 degrees in front of him, so he can't perceive me right now. And then, oh, yeah, there he goes. And he'll trundle off and try and get away from me. So now his line of sight's blocked, or maybe not. Maybe he's doing it again. He doesn't like it, does he? I'm sure he'll do it again soon. So yeah, I mean, you know, AI is one of those things where it'll take a while to sort of figure out what systems we need. Let's just switch the shooting back on just for giggles. So he can, you know, he can fire back. Let's fly over there a second. Oh, let's just go to play in selected viewport. So this guy, one of the things that you see is that this guy kind of shoots while he's moving, which is a bit dumb. And now he'll kind of keep shooting while he's turning around and stuff. It's obviously just needs a conditional check on there. He's got a really long wait on his shooting, so he can't do it all the time. Let's just switch off, make sure he's got some kind of... You see that the path, the sort of area of vision on this guy is probably a little bit too large for this level, so he can pretty much see a whole way across it, which is why he's responding a bit too much. So yeah, that's the AI system as is. I'll probably do another video soon to show you some more debugged version of the character, because obviously this is still just a little bit not sorted out yet. Well, yeah, hopefully you'll understand a bit of what the AI can do in Unreal Engine so far. There's a long way to go still, put it that way. But there you go. Yes. See you later.